So here in this question, there is a block attached to the spring is kept on a smooth horizontal surface. Now the free end of the spring is pulled with a constant velocity u horizontally. Here if we are pulling it with constant velocity u, initially the spring is in natural length. So this block will be in rest. Then the maximum energy in the spring and the block system during the subsequent motion is what? So they are asking the maximum energy. Okay, we have to find the maximum energy. Okay, so if we want to find the maximum energy, so what we have to do is we have to analyze this first. So here I have a block and here I have a spring. When I am moving with a constant velocity u, this will be in rest. Okay, this will be in rest. So now if I keep on pulling this spring will extend. Okay, this will extend after a particular extension. When it reaches the maximum extension possible, this block will try to move with a velocity. For example, let me take it as v. At that point of time, okay, the maximum energy stored in the spring. Okay, so that maximum energy is going to get converted into your kinetic energy. Then what will happen? Again the spring will come to natural length. So when the block is moving, okay, the maximum velocity attained by the block is v, means then the kinetic energy, there is maximum kinetic energy of the block when it is moving is nothing but the your maximum energy stored in the spring. So that is what our duty. We have to find what is this velocity is. We have to relate this velocity with the initial velocity of the spring. Okay, so that we can do now. So here what happens is initially it is in rest. Okay, when it attains maximum extension, again it will move and again it will come to rest. Again the constant velocity will be applied. Again the same process will get repeated. Again it will come to rest and move, rest and move. It comes under the topics of oscillation. Okay, it comes under the topic of oscillation. Okay, in relative to the spring, your block is going to oscillate. Okay, if it is oscillating, okay, in ground frame, okay, in ground frame, if you see, okay, if you see the relative velocity of the block, okay, relative velocity of the block with respect to the spring, what we will get? It will be v minus u. Am I right? So in initial stage this velocity is 0. Initially it is in rest, so you will get minus u. So this is the relative velocity of the block. One second, I'll erase this. Okay, so relative velocity of the block with respect to the spring is this. When it starts, okay, when it starts motion, this velocity will be increasing. So initially when time is equal to 0, your relative velocity is minus u. Okay, your relative velocity is minus u, but after some time this relative velocity is going to increase. Apo the equation for this relative velocity in oscillation will be minus u cos omega t. Okay, this comes from oscillation. When t is equal to 0, cos 0 will be minus 1. This satisfies this. Okay, so here this omega we have, this is nothing but root of k by m. Okay, it is root of k by m. So here, when the spring attains the maximum length, the block starts to move. Okay, the block starts to move. That is nothing but the condition when omega t which is equal to pi. Okay, so when the omega t which is equal to pi, you will be having maximum velocity. Okay, the maximum velocity will happen only in this condition. So here we can substitute this omega t as pi in your relative velocity. So I will get cos, sorry, not sine, it is cos only, cos of your pi. So what we will get? We will get minus u, cos of pi is minus 1. We will get plus u. Okay, if we are getting the relative velocity as plus u in lab frame, okay, so in lab frame what will be your v? Okay, so here we have this v is nothing but, if I bring this left hand side, I'll get u relative plus u. So u relative plus u, so we will get u plus u, which is 2u. This is what the maximum velocity possible of the block. So as I told you before, the maximum possible velocity is nothing but your 2u. So half m, here if you substitute 2u, we will get 4u square. Here your maximum kinetic energy possible is nothing but, if I cut this, I'll get 2. So 2u square. Okay, sorry, m also I missed. 2mu square is the maximum possible, okay, maximum possible kinetic energy.